100% security is never possible because there's always a way in. So a little bit of background. We're going to talk about VMX. So basically what this is it's a hypervisor. So if you're running VMware or Zen, you're actually running a VMM, which is just a way to kind of abstract the operating system from the hardware. So you can run multiple operating systems as if they were applications. Unfortunately, the implementation of VMX can be enabled and disabled at any time, and it was designed to increase performance and the amount of your system that you're able to use. So rather than having 3 very lightly loaded mail servers, you can now have one that's going to be much heavier loaded, but you're still going to have some of the same isolations, at least logically. So from a maintenance and management perspective, VMX was kind of designed with the performance and the cost metric. There's another type of virtualization on the IBM mainframes, which is much, much more expensive, but has much stricter isolation. And that was kind of down the security. Though I would say, seeing how the latest market share of Google and Apple, and they're using the commodity cloud, I would say that the performance and the cheap, the low cost of this VMX in Intel is winning out over the more expensive but more secure ZOS hypervisors. So this is a pretty old attack, actually. This was back in 2006. It's a blue pill. It's a rootkit written by Joanna Batowska, part of Invisible Things Lab, and was presented at Black Hat. And essentially, the issue with VMX is that there's no way to know if you're in a VM or not, if that VM is on purpose trying to be stealthy, and unless there's already a hypervisor in that kind of VMX slot, there's no authentication needed. There's not like a Windows dialog that pops up and says someone is trying to start a hypervisor in the architecture. So the issue is if modern Windows systems up until 7 didn't by default run a hypervisor, and so Blue Pill could just come in and say, oh, I'm by default authenticated because I'm running on this system, and then it allowed you to get more privilege in the operating system, which gave you a hidden execution environment, and you were completely safe from defensive software. You had more privilege than your anti-rootkit and anti-malware. This is a very, very stealthy rootkit and one that's very hard to detect. And so this is kind of what I said right here is basically Blue Pill, because there's no authentication either for the user or from the machine. As long as there's nothing there in that kind of slot, you could say, Blue Pill can just stick itself in there and then be able to subvert your system. So what went wrong here? Basically, you have an environment that if you have some kind of secure enclave, that secure enclave can many times be used more effectively by an attacker. And so an attack, basically this hypervisor slot is protected using hardware features to prevent an operating system from breaking out of that or violating the isolation guarantees. Unfortunately, that's also the perfect spot for a rootkit. And so these technologies really need to be given extra attention when they're architected. And basically, if all they provided was a single instruction that you could guarantee would tell you if or not there was a hypervisor, you could at least detect if you were being compromised, but they don't have that. So that's kind of this implicit authentication once you're running that you'll see many times in hardware. We're going to jump a little bit to some much more recent work, 2014, by Corey Kallenberg and Zeno Kova out of MITRE. They showed that the reference implementation, which is provided by Intel, is open source, and which is then pretty much copied and pasted into all the different BIOS manufacturers, allowed you to escalate from a user application, which is the lowest privilege. That would be a Ring 3, so that would be your calculator or Notepad or Microsoft Word, all the way to the most privilege, which is your firmware level. So they could infect your BIOS from user space. And that was a very extreme attack in the sense that they were able to go from the lowest privilege on the system to the highest privilege, even more privilege than a hypervisor. And so this was a very scary attack. Really, the worst part about it is that even though it's been fixed in the reference implementation, people don't patch their BIOSes very often. It's not something that kind of pops up in the corner and says, hey, you have a software update available. It's something that requires a lot more manual interaction. And also it can be a little bit risky. Sometimes if the power goes out while you're doing that, you can brick your system. So that's the scary part, is that these attacks will be around and vulnerable for quite some time. Now we're going to talk about the work I presented at Black Hat. It's called More Shadow Walker. It basically showed that you could misuse the existing x86 hardware to be able to hide malware from operating system protections and antivirus. And so this will allow you to bypass anti-kernel patching, so that would be Microsoft Patch Card, and antivirus could not detect modifications to code. And it did this by providing a split view of memory, code versus data. And so if you have a region of memory in an application, say you want to check the Word application, you'll know where it is in memory and you'll read through it and verify that it hasn't been compromised. Unfortunately, with my technique, if you were to read memory in the CPU level, it would actually go to the benign copy. But if you were to jump to that memory and actually run Word, it would give you a different output. And so there's no way to actually measure what code is running on your software. You can completely kind of remove all trust in the ability to measure your system. So that was pretty scary, but again, very rare attack, but something that shows kind of these issues with x86. This is actually one of my favorite, 2013. It's called Stepping Pwns. It showed that you could pivot through a printer, and that would allow a remote shell from behind a firewall, reverse shell. And so the kind of the attack scenario is this researcher would email an organization with a PDF that had a firmware update for the printer in that PDF. Since this wasn't, a Windows virus, it would not show up as malicious by any of the antivirus software, even ones that, like FireEye, that kind of run in a VM or do behavioral analysis. But when you were to print that document, that PDF, so he would ask, the HR person, hey, here's my resume, please send this out, and print it out and send it out to people. As soon as the printer received that PDF job, it would upgrade its firmware to one that he had compromised, and then open a reverse shell through his firewall. He could then pivot from that and infect IP desk phones and smart switches for a stronger foothold. He went one step further and created a network inventory automatically of all the phones, printers, and switches that he had been able to compromise, and then monitor them for being maybe reset. So if you went and you detected something was screwy with your phone and you kind of reset the firmware, it would detect that that phone had been reset, and they would reinfect it. So the only way to remove his compromise from your network would be to shut down every printer, IP phone, smart switch, and reflash them all offline at once, and then bring them back up. So this was a very impressive attack, showing that especially now with bring your own device. Bring your own device is traditionally used in the concept of mobile, but there are many devices that are running code on your network that are not kind of your standard Windows or OS X or Linux systems. And unless you have you don't have an antivirus or a patch solution for your printer or for other devices on your network. And so that's something to think about, is that you're implicitly trusting in the resilience of the operating system running on all of these devices. And typically they don't provide the access for you to go in and examine that. They're very rarely open source and don't allow you to load arbitrary code on there like an antivirus for